So folks, to catch you up from yesterday, here's what we discussed since we weren't able to have class. First question I wanted you to be comfortable with in today's warm-up is a question like 3 and 4 here. Notice that compared to Wednesday night's homework with the x value being 0, these values are not 0 here for x. The x is 1 in this case and 3 in this case, but it still calculates slope the same way. So we'd have 10 minus 4 over 3 minus 1. And that's a slope of 6 halves, which results ultimately in a slope of 3. And that's good. However, I still need to find my b value. Remember, we need m and we need b. Those are the two things we must have to make our equation. But what I can do is I can take the information now that I know, which the slope of 3. So I know y equals 3x plus b. And at this point, I can pick either point to plug in. So I'm going to use the 0.14. So I'll put 4 in y's spot. I will put 1 in x's spot. And that'll help me find b relatively quickly, subtracting 3 from both sides. The b value is 1. So I have a b of 1 and an m of 3. Altogether, y equals 3x plus 1. Wanted to make sure you're comfortable looking at that and seeing those scenarios when we don't have a slope or we don't have a b value that's easily accessible because in this case, the x value is something different than 0. The same thing happens in 4. Notice that my x's are different values, so I will have to do some work there. Here's some quick work in number 4. Slope is negative 1/4. And I'll go ahead and pick an ordered pair to plug in. Doesn't really matter. I'll pick the second ordered pair for no reason. So B is negative 2. So altogether, I have final answer being y equals negative 1/4 x minus 2. Just needed to make sure you're comfortable with that scenario. We're going to see that very soon. Next thing I need to make sure that you're comfortable with is a story problem such as this. It's a little bit more detailed, so here goes. After reading this, you'll see that the renewable energy sources in 2007, so in this case here, yielded 105 million megawatt hours of electricity used. And then it shifted gears in 2012, so a couple of years went past, it has increased to 219 million megawatt hours used. The first thing we're challenged with doing is making a linear model. That is like a linear equation, y equals mx plus b, relevant to the scenario. But we're doing it since the story began. So here's what we have. The story begins in 2007. So in 2007, that's when the story begins. That is what we're going to call year 0. In our story, it's year 0. So in year 0, let's see, how many were there? 105 million megawatt hours. So this is million megawatt hours. I'm just abbreviating there. I'm going to leave that as 105. I'll add the millions back in at the end. Then the story continued. It pushed forward a few years. So a few years went by, and now we have a new scenario. It goes to year 2012. So it goes to 2012. So between 2007 and 2012, we're now working in year 5 because 5 years have passed, and the result was 219 million megawatt hours. So now what I have is my 2 ordered pairs, and now I can do what the question asks, which is to write a linear model that represents the number of million megawatt hours used or generated as a function of the number since 07. So basically saying the story begins in 07. So let's calculate slope. We're looking at slope being 219 minus 105 over 5 minus 0. So that would be a slope of, 114 fifths. So it's 114 fifths is a slope. That's non-reducible. And there's my slope. And hopefully we know from the homework on Wednesday, you checked your homework, the B value is actually stated here already for us because the X is 0. That's my y-intercept. So 105 is actually the B. So I have M and I have B. Now I'm looking at my equation being 114 fifths X plus 105. There's the model. So this model will predict the future for this facility that has these this hydropower, this power plant. Last part of the question, it says is use the model here to predict the future. So 2017 is the year. So relevant to the beginning of the story, in 2017, it is year 10, meaning 10 years have transpired since the beginning of the story. So I would take my 10 and I would put it up in X's spot. So now I'm looking at Y equaling 114 fifths times 10 plus 105. That's 228 plus 105. And that will be a total of 333. Now, connecting back to the story, that's 333 million megawatt hours in 2017. This is the final part of the question. So its question is twofold. Again, generate the model based upon past events and predict the future based upon the past event pushing forward, maintaining the current slope as well as the y-intercept. So hopefully you had that filled in. Now you can work on the homework assignment that is posted on Blackboard as well as on the board. Thanks, folks. Hope you had a great day. I'll talk to you soon.